In this tutorial, we're going to take a quick look at the binary number system, and in particular we're going to look at how we can convert between binary numbers and denary numbers. So the first thing that we need to understand is what the binary number system is. Now the binary number system uses only two symbols in any number that we write down. It uses the symbols 0 or the symbols 1, and it's based upon powers of 2, hence why it's called binary, bi meaning 2. Now, in order to understand how binary works, it's useful if we take a quick look at how denary works. Now, denary is simply the posh name for our number system that we use on a day-to-day basis. We sometimes also call this decimal. And it uses powers of 10, possibly because we've got 10 fingers, and it uses the symbols 0 to 9. Now, if you cast your mind back to primary school, you might remember yourselves writing a number like this, 375, and then dividing it into discrete sections. And at primary school, you were probably told that this was the units column, this was the tens column, and this was the hundreds column. Therefore, this column here is worth 1, this column is worth 10, and this column is worth 100. And practically what you've actually got here is this column is actually 10 to the power 0, which is 1. This is 10 to the power 1, which is 10. And this is 10 to the power 2, 10 times 10, which is 100. So we get the number 375 by simply expanding this in saying, okay, we've got a 3 in the hundreds column, so we've got 300, plus we've got 7 in the tens column, so we've got 70, and we've got 5 in the units column, so we've got 5 there. So this is actually 300 plus 70 plus 5, which gives us 375, which we always knew we had written up here. So that's how the denary number system works. It's a positional value system, meaning that the position that this digit is in gives it its value. This worth 1, this worth 10, and this worth 100. Now that we've reminded ourselves how denary works, we can take a look at how binary works. Because in the binary system we said we'd only got two symbols, the symbols 0 and 1. And instead of using powers of 10, we're using powers of 2. So let's write those binary place values down. We start from the right hand side here, and we've got a 1, a 2, a 4, an 8, a 16, a 32, a 64, and 128. Notice they double each time. 1 becomes 2, 2 becomes 4, 4 becomes 8. If we look at what those place values actually are, based upon powers of 2, then this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 times 2, 2 to the power 3, 2 times 2 times 2, all the way up to here until we get to 2 to the power 7. So let's write a binary number down then. Suppose we put a 0 in this column, a 0 in this column, or 1 here, a 0 there, a 0 there, 1, 0, 1. We then need to convert this number into denary, into our number system. So all we need to do is write down each place value that we put a 1 under. So we've got a 1 under the 32 column, so we've got 32, plus a 1 under the 4 column, so we write 4 down, and then a 1 under the 1 column, so we write 1 down. So we've now got 32 plus 4, which is 36, plus 1, which is 37. So the binary number 001000101 is 37 in denary. Obviously, we can do this process in reverse. Let's suppose, for instance, that we want to work out what the denary value 28 is in binary. All we need to do to get 28 into binary is to start with the highest place value here, 128, and say, in order to make 28, do we need 128? And the answer is no, because that would bust us. Do we need a 64 to make 128? No, we don't. Do we need a 32? No. Do we need a 16? Yes, in order to make 28, we do need a 16, so we write a 1 in that column. Do I need an 8? Well, 16 plus 8 would give me 24. So, yes, I do need one of those. So we need to write a 1 into that position here. Do I need a 4? Well, this makes 26, 16 plus 8. A 4 would bust me. So again, I put a 0 in there. Do I need a 2? Yes, I do, because that then makes my 28, so I don't need a 1. So the binary value for 28 is 0001 1010, which is 16 plus 8 plus 2 gives me 28. And that's how you convert between binary to denary and from denary to binary. And that concludes this tutorial.